guys, right? So this will be the first video on MCQ discussions of past papers in physics, right? So what I am planning to cover in this is not the complete paper but the mechanics and the waves part, right? So yes, this will be completely based on the mechanics and the waves part. I will be covering all the possible questions in mechanics as well as waves, right? So this will be very helpful for your exams, right? So please do not skip until the final this thing, cover it perfectly, yeah, and then try to get something out of the lecture, right? Okay guys, right? So like it's going to be like we are not going to just talk about the questions. Based on each question we will discuss. I will quickly remind you certain theory parts, right? Theory parts, so it will take some time, right? So can't help. So if you need to cover it perfectly, you will have to just get along with it, right? So okay guys, so let's move on to the first question then. So in the first question, what they are asking is yes, in the first question, simply they are asking the dimension of Planck's constant. They're asking the dimension of Planck's constant, right? We'll see what that is. First question, right? Planck's constant equal h f. So what is the Planck's constant? Planck's constant is this h. So h is subject e over f, right? So what is e? E is the energy, right? E is the energy. F is the frequency, right? So if we are supposed to get the dimensions, right? So dimensions of Planck's constant, right? We have to include the dimension mark. So when you include the dimension mark, so to the left and the right. So when it is a division, you can divide separately the complete dimension. It's like this. You include it as this, right? But when dividing, you can divide it separately, right? As in this way. In that case, Planck's constant is going to be what? E, energy. What is the dimensions of energy? Dimensions of energy, if you can't remember, you will quickly have to know the equation of energy. What is the equation of energy? Force into displacement, right? So force into displacement over frequency, right? So you definitely, obviously, you know this the frequency of the dimension of the force, right? So that is going to be m l t minus 2. You need to know, right? So if you further do not know that, you can go for force is equal to m into a, mass into acceleration, and then come up with this, but I'm not going to do that. So displacement is L, frequency is what? T minus 1, right? So you need to know frequency is 1 over time, right? So therefore the frequency's dimension is T minus 1, right? So okay, so when you cancel, so T minus 1, T minus 2, it's going to be minus 1 here, right? So it's going to be m L squared T minus 1. So the answer is going to be what? ml squared T minus 1, the second option. To the let us move on to the second problem. In the second problem, what they are saying is figure shows the scalar of a micrometer screw gauge, right? They have given a micrometer screw gauge when the spindle and the anvil touch each other, right? So what is the reading that they are mentioning about when the anvil and the spindle is touching each other? It's the initial reading. Initial reading means like when actually what should happen when the anvil when the anvil touches the spindle, right? So actually the reading should be exactly zero. Right? Reading should be exactly zero. But here in the figure A, if you see the figure A, the reading is not zero. When the anvil is touching the spindle, the reading is not zero. If it is not zero, then what does it talk about, right? So it says that there is a zero error. Right? So figure A says there is a zero error, right? Okay. So we need to check whether it is a positive zero error or it's a negative zero error, right? So what is it? So the zero is visible. And it's like what number is coinciding? Which number is coinciding with the this thing? Which number is coinciding? The 3. The 3 is coinciding, right? 0, 1, 2, 3, 3, right? So it means what? It means the reading, like this is a positive zero error, like because 0 is visible, right? 0 is visible, and like it has positively moved up, right? +3, right? So it is a positive zero error. So it's if it is like if zero is not visible, right? If the zero is not visible, what happens, right? If zero is not visible, it's like if 48 or something is there, right? 48 is here, 0. This is a negative zero error. Now it has come somewhat behind. It has come somewhat behind, right? There is a small gap actually, right? This denotes that initially there is a small gap. Even when you close the angle and spindle, there is a small gap. That gap keeps on adding to every measurement. So whenever you make a measurement by using this kind of a micrometer screw gauge, you need to subtract that positive zero error, right? So in that case, first of all, you need to find what? You need to find the this thing, what you call the least count. First of all, before you make any measurement using this screw gauge, you need to find the least count. Least count of a micrometer screw gauge is found how? Pitch over what? Circular scale, right? They have told that the pitch is what? 0.5 millimeters. They have told the pitch is 0.5 millimeters, and then they have mentioned that there is 50 circular scales, right? So 50. So what is it going to be? 50 means 0.01 millimeter. So this is the least count. This is the least count. So now shall we obtain the reading of the figure A, the zero error? So from 0, like actually, how do you obtain zeros? How do you obtain readings? You need to first of all, in a micrometer screw gauge, how do you obtain readings? Reading A, right? Reading A. How do you obtain readings? Main scale reading plus vernier scale reading, right? What is the main scale reading? It has passed which number in the main scale? 0. It has passed 0. So what is the number coinciding with? What is the number of the vernier scale which coincides with the main scale? It is 3. 3 into least count. Sorry, it should be least count, right? Vernier scale. Vernier scale. Vernier scale. How do you write? The number that is coinciding and into the least count, right? 0 plus 3 into what is the least count? Least count is 0.01 millimeters. So reading A is what? Reading A is 0.03 millimeters, right? Okay. So now let's get the reading 2. Let's get the reading B. Let's get the reading B. Reading B. Okay. So in the reading B, what they have given here is it has passed what? 3.5, right? It has passed main scale plus vernier, right? It has passed what number? 3.5 millimeters. It has passed 3.5 millimeters plus main scale, vernier scale. Which number is coinciding? 30. Which number? 31, right? 31. 31 into least count. Least count is what? 0.01. So this is 3.5 plus 0.31 millimeters. This is going to be 3.81 millimeters, right? So now is this the reading of that object? No. Always when you take a reading from this kind of a micrometer screw gauge, there's going to be a positive zero error. When there is a positive zero error, you need to do a small subtraction. I told you always the small amount is in addition, right? You need to subtract that small amount from each reading, right? So final reading is going to be what? Final reading is 3.81 minus the zero error, right? Zero error, right? So 3.81 minus zero error is what? 0.03. 0.03. It is going to be what? It is going to be finally 3.78 millimeters. So this will be the answer. That is the third answer. Third question is waves and oscillation question, right? So in this, of course, this part, the third question belongs to the loudness of waves. Like in waves and oscillations, it belongs to the quality of sound part, right? So when you consider quality of sound, you know there is three qualities of sound: pitch, loudness, and once again quality of sound. When it comes to quality of sound, it depends on intensity of the sound. So this is going to be an intensity question, right? So it's a pretty straightforward question if you know the equation that should be applied to solve this question, right? So it is once again pretty straightforward, right? Okay, the threshold hearing of normal human ear, I know the threshold frequency, I know they have given that to be as intensity, that they have given that to be as 10 to the power minus 12, and then this corresponds to a sound intensity level of what? This corresponds to a sound intensity level of what? We need to find that. The threshold of hearing normal human ear is 10 to the power minus 12, right? So it's like this. Actually, the threshold value of the intensity is I know, that is 1 into 10 to the power minus 12, and also what they are asking is the intensity level corresponding to I, which is 1 into 10 to the power minus 12. So simply we have the equation what? Sound intensity level, right? Sound intensity level is equal, what is the equation? 10 log 10 I over I naught, right? 10 log, we need to find the sound intensity level corresponding to which frequency, which intensity? This I. What is it? They have given that to be as 1 into 10 to the power minus 12. But what is the threshold frequency I naught? The threshold intensity, it is also 1 into 10 to the power minus 12, right? So this to this cancels. What is it? 10 log 10 1, right? What is this? Log 10 base 1. What is this? Log 10 base 1 is 0. Log 10 base 1 is 0. So 0 decibels. This will be the answer. This is going to be the answer is going to be the first one, right? Not go for the fourth question, right? So the fourth problem, it says the figure shows the velocity time graph of an object, right? Velocity time graph of an object that performs a motion, like velocity time graph of an object moving along a straight line, right? Moves along a straight line. What is the average velocity from t equal 0 to t equal 4 seconds, right? So it moves in a straight line. The graph is given as this, right? The graph is given as this, right? So this is 3, 3, 3, 4, alright? And this is 1, okay? So this is a T graph. So what kind of a motion is this particle performing? What kind of a motion? In the first place, what kind of a motion? It performs a uniform velocity motion. It performs a uniform velocity motion, a constant velocity motion, right? So if it is a constant velocity motion, how do you find the average velocities of a constant velocity motion? Very simple. That is, the average velocity is equal to the total displacement, right? The total displacement traveled by the object divided by the total time taken. Total time taken, right? So the average velocity can be found. What is the total displacement? Total displacement of this particle can be found by using what parameter? In a VT graph, the gradient gives you what? The gradient gives you the acceleration. In a VT graph, the area gives you what? The area gives you the displacement, right? So simply we have to find the, if you need the total displacement, you have to find the total area. Total area is, how can we find the total area? 3 into 3, this area plus this area. 3 into 3 plus, what is this area? 1 into 1. 1 into 1. What is the total time taken? 4 seconds. 4 seconds, right? 3 into 3 is 9 plus 1 over 4, right? Is equal to 10 over 4, 2.5 meter per second. So the answer is going to be the third one, right? So to do these questions, you do not have to take a lot of time, right? So you need to quickly solve, right? First few questions are given for you, like it's very easy questions. First few questions, you need to get that into your mind and quickly solve and save some time from these questions, so that you can spend some more time on the latter part of the paper, right? So that is how you need to try the questions, right? So if you recheck these questions and all, it will take a lot of time. Do not go to do these things, right? So because once you can completely do the paper overall, and then you can, if time is remaining, uh, obviously it will mostly not. If it is remaining, you can recheck your answers, right? So if not, do not go to do these things. It's going to take a lot of time. In that case, you will not be having time to solve the latter part of the paper, right? So because of that, try to save as much as possible. So let us discuss the ninth problem, right? So in the ninth problem, it says positions of particles of a transverse wave traveling in x direction at a certain instance is shown in the figure. A pair of particles with same instantaneous velocities is okay. So this question, right? Ninth one, right? Ninth question. Simply, it's going to look like this, right? So this is the what? It's like this. It's going to look like this, right? Right. So this is what graph? Displacement time graph, right? So this is the plus amplitude, and this is the minus amplitude, the maximum amplitude and the minimum amplitude, right? So to represent this kind of a motion, it will be easy. So this is what actually, this is a displacement time graph of a simple harmonic motion. To represent a simple harmonic motion in common, I will refer to a pendulum bob, right? Okay. So let us consider a pendulum bob. When it is at this point, it is somewhere here, right? Okay. When it is at the maximum amplitude, it is somewhere here, right? It has moved plus r distance at this point, right? Which means, right? And then once again it comes to the, once again when time passes, in the next t/4 time, it comes to what point? To the initial mean position, right? So within the next t/4 times, it will move to its negative amplitude, right? It will move to its negative amplitude at this point, right? Negative amplitude, at its negative amplitude. In the next t/4 time, right? It will move once again back to the original position, right? The mean position. This is one oscillation. This is one oscillation, right? If it performs one oscillation, right? So this is how the displacement will vary with time for one oscillation, right? So this is point A. Point A is when the particle is at this point. Point B is somewhere here, when the particle has moved a distance. Point B. Point B. So at the point B, it is moving with in this direction. In this direction. Okay. Point B. Right. At point C, when it is at point C, it has moved. It has moved to the top, and it is returning back. Right. It has moved to the top and returning back. What has happened? It has moved to the top and it is returning back. C. C point is also coinciding on B. C point is also coinciding on B, but it is moving in this direction. This is C. C. And then D. D is which point? D is once again when the displacement is 0, which means this, right? And then what is E? E point is, it's like D point is, it has moved to the top and returns back. So E point is, it has moved to the top right? And returned back to the main position, and once again has moved to this point, which means somewhere here, somewhere where, somewhere here, E, E, point E. So at this point E, it is moving in this direction, right? It was moved to this point, return back to this, now moving in this direction. E. Once again, it will reach to this point. This point means it will reach to the negative amplitude. Once again, EF means it has what? Gone to the top, returned back, gone to the negative amplitude, and returns back. Returns back. It is the same point. F returns back. Returns back. Alright. So at which point the velocity is same? At which point the velocity is the same? Right? So you know, according to V is equal to omega r squared minus y squared. Omega is the same, r is the same, omega constant, r constant. So the velocity depends on whom? It depends completely on the velocity depends completely on the displacement. So at which point the displacement is the same? At which point the displacement is the same? It doesn't matter positive or negative. It doesn't matter positive or negative. Why? Why doesn't matter? Because it's squares. There is a square. Displacement are same at which points? B, E, B, C, B. The displacement is y. C is also displacement is y. F is also displacement y. E also displacement y, negative y, negative y. But when you apply it to this point, it's the same. It's the same. You can, if you are supposed to consider the magnitude, the speed at B, C, F, and E. At B, C, F, and E, speeds are the same. Speeds are the same. Why? Why is the speed same? Because the distance is the same. You can see that, right? Symmetric. Symmetric. Distance are the same. The distance is the same. The speed is the same. Speed means only magnitude, no velocity. But when it comes to velocity, this and this are not same. Why? This is moving in that direction. C is moving in this direction. Not same. E and F not same because E is moving in this direction. F is moving in that direction. Not same. Velocity is not same. But if you see the velocities at F and B are same. F and B. Velocities at F and B. Obviously, you know magnitude is the same because of this displacement or the distance. Magnitude is the same. Direction is also the same. So velocity of F and B is the same. Also, velocity at C and E is the same. C and E is the same. So the answer should be what? The answer given is B and F, right? So the first answer, right? So the velocity at point B and point F is the same. Goes up, comes down, and moves up, right? So same displacement, like I mean, same displacement, right? Displacement, same displacement. Magnitude same, direction same. You do not have to worry about all these, analyze all these things, right? Just for you to understand, right? So I just did all these things. Okay, right. So next, what we have to discuss is the 11th question. Let's see how it is going to be. The 11th problem. So in the 11th problem, they're saying two identical transverse waves of frequency. What? Two identical transverse waves of frequency. What? 300 hertz and speed what? 30 meters per second. Right? Are moving in opposite directions. Right? Are moving in opposite directions. What happens when they move in opposite directions with same speed? Actually, not the speed. Actually, what should be the same is the frequency. When they move in the same frequency in the opposite directions, as a result, when they superimpose on each other, what you would be able to observe is what kind of a wave? A standing wave. One phenomena of standing wave is going to be, one phenomena of superposition of wave is going to be standing wave. So the standing wave, when they superimpose, is going to be in this way. right? Going to be in this way. All right. So superimposed standing wave, right? So what they are asking in the question is what? So when you consider a standing wave, right? When you consider a standing wave, right? Yeah, obviously, see, the frequency of the standing wave is definitely going to be frequency of the standing wave is definitely going to be the same as the frequency of these guys, right? 300 hertz. And also, if you see, the lambda of the standing wave is also going to be the same as this lambda, right? Lambda. Shall we find that lambda? From V equals F lambda, right? What is the speed of this wave? 30. What is the frequency? 300. What is lambda? Lambda is going to be 0.01 meters, which is what? 10 centimeters. So 10 centimeters. Also, if you consider, right, this to this will also be what? 10 centimeters. Actually, it will also be 10 centimeters. So what do they ask now? The wavelength is also going to be 10 centimeters, right? Okay, this is a wavelength and this is also a wavelength, right? Pretty much. What do they ask now in the first place? What they're asking is the distance between a node and its adjacent antinode. The distance between its node and its adjacent antinode, right? So, what is a node? A node is a position or a point where it is not free to move. A position or a point or a particle which is not free to move. So can you show such points? Obviously, you need to know when a standing wave is considered. It keeps on vibrating. It keeps on vibrating in the same place. It's not going to propagate. It's going to vibrate in the same place. How actually crest is going to turn into a trough is going to turn into a crest. Likewise, it is going to simultaneously keep on happening, right? So actually, node is a point which is not free to move. So this is a node. This is not free to move. Node, 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 right? So what are antinodes? Antinodes is the opposite. The points which are free to move. Antinode, antinode, antinode. So what is the distance between a node and antinode? Right? D. D. How many D's are there? D. 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 In one wavelength, 4 D's are there. 4 D's are there in one wavelength, right? So D is going to be 10 over 4. D is going to be 2.5 centimeters. The answer will be the first one, right? First. So let us move on to the 16th problem, right? So the 16th problem is also going to be based on oscillations, right? So waves and oscillation part. So it says a particle of mass m performs a simple harmonic motion, right? So there is a particle, right? So we are going to discuss what problem? 16th problem, right? There is a particle of mass m. It performs a simple harmonic motion. To represent a simple harmonic motion, I will denote a what? I will denote a simple pendulum, right? Motion of a pendulum, right? So okay, it says if the maximum velocity and the maximum acceleration are given by v and a. So what do they say? Maximum velocity is given by v, maximum acceleration is given by a, right? So let's assume the amplitude. Let's assume the amplitude is simple r, it seems. So what is the amplitude? This is the amplitude, right? Okay. So what are the equations that we okay? So first of all, let's see what do they ask. The angular, an expression for the angular velocity. Okay, if you see the solutions are given in terms of v, m, and a. So in certain questions, certain solutions, m is not there. So somehow v and a is there. So somehow we need to relate this v and a, velocity and the maximum velocity and the maximum acceleration. So shall we first of all write down the expressions for maximum velocity and the maximum acceleration, and then let's see what we can do, right? Let's not first of all focus on omega, how to find omega. Let's first of all write the maximum expression for the maximum velocity and the maximum acceleration, right? So how can we do that? If you see A max, right? V max is what? V. It is given, right? V max. V max. So what is the expression for the velocity? Velocity expression is omega, right? Root r squared minus y squared. So the velocity, like omega and r constant, velocity directly depends on y. When y is minimum, A is maximum. When y is minimum, when the displacement is minimum, velocity is maximum. So y min is what? Y min is 0. Therefore, V max is given at omega root r square. So V max is what? Omega r. Omega r. Right? So according to this, if we substitute V max is V omega r, first equation. Also, shall we write another expression for maximum acceleration? So A max is equal to what? Let's not write the minus mark, omega squared r. Let's only consider the magnitude for the time being, right? So forget about the minus mark, the direction. A max is equal to omega squared r. So you will see when the, sorry, not r, y, when the displacement is maximum, acceleration is maximum. So what is the maximum displacement? Y max is what? Maximum displacement is the amplitude r. So A max is equal to omega squared r. What is A max? They have given E omega squared r. So what do you need now? You need omega, right? So there's omega here. So what you can do is divide 2 by 1. You divide 2 by 1, you're going to get E equal omega squared r V omega r. Omega, this cancels, this cancels. A over V is equal to omega. So the answer is right. So next, what we have to discuss is the 19th, right? So yeah, 19th. So in the 19th question, they have given you four metallic rings. They have given you 4 metallic rings and uniform metallic rings. These are right, and they have given they are different. They have different radiuses, right? Uniform metallic rings with different radiuses placed as shown in the figure. You have to find the center of gravity of this system. You have to find the center of gravity of the system, right? So to be honest, to solve these questions, there's plenty of methods. There's plenty of methods. You can go with the traditional method, that is by applying moment, like taking moment around the system and all. Yes, but I will not, because like most of you guys would know. I hope you all know that. But let's go from a different approach. If it seems easy, please try to solve this kind of problems by using this method, right? So it's pretty, like, obviously what I feel is this method, what I'm going to say is somewhat easier than the traditional method, right? Okay, so first of all, it's like this. I will draw the system, right? So there is a larger there's a larger circular radius, a circular ring, where might be the center of gravity of this at this point, at the center, right? What is the radius? This is, as they have said, it is, but D is 3r. D is 3r. And then another radius is, another circle is there. Another circle is there whose this thing is 3r, sorry, 2r. Somewhere like this, right? Somewhere this way, which is 2r. At this point is what? X. Another same kind of circle, a ring C is there, a C. Right? C. Center is at this point. What is this? 2R. Right? And then another smaller circular ring is there, which is radius is R. Right? Radius is R. Radius is R. Right? Okay. Yes. Radius is R. Right? This R. Now, first of all, since you are dealing with center of mass, since you need to find the center of mass, like if you consider these as object as it is, you're going to, things are going to get complex. So better always when you come across these kind of center of gravity problems, right? Better represent them as point particles. Better represent them as point particles, right? With their appropriate masses. So now, for this, what I'm going to do is I will assume let uh, let the mass per unit length, let mass per unit length be simple length, right? So each of this wire, if we consider a unit length, 1 meter, or it's a unit length, let's assume the mass is same, right? Mass per unit length is same, linear density, right? So then what is the mass of 3R? Mass of 3R, mass of 3R, which is C. Mass of C is what? What is the length, total length of 3R? 2 pi into 3R. This is how you find the total length. Circumference, right? 2 pi to 3R. So into what? Linear density. Like total mass is given by what? Linear density, or its mass per unit length. Sorry, mass per unit length into the total length. Total length is the circumference. Circumference is given by 3 to 6 pi R m, right? So this is 6 pi R m, right? Okay. So similarly, mass of B, mass of this is C, this is B, right? Mass of B. What is the total length? The radius is 2R. So 2 pi into 2R m, which is 4 pi R m. So similarly, mass of B, and so this is D, right? Sorry, this is D. This is D, right? Mass of C is also 4 pi R m. 4 pi R m. What is the reason? 4 pi R m. Why? Because the radius is also the same as B, right? So yes, and finally, mass of, what is it? A, right? Mass of A, 2 pi. What is the radius? Radius is R into M, right? So if you consider, like let's ignore the 5 rm part. So this, let's consider this as 6m. This is 4m. This is 4m. If you get the simplest ratio, this is 2m, right? So now I will represent them as point particles, right? Okay. To represent them as point particles, let's assume it this way. So D, the center of D is at which point? This point. What is the mass? 6m. 6m. D, 6m. From here, from 6m, right? At a distance x, right? Which is 3r, distance. At a distance x, what is there? That is the point x. At a distance 3r is point x, right? From there, x onwards, from there, at 2r distance, what is it? That is C. 4m. 4m is there, right? Okay. So from x at r distance, what is there? From x at r distance, A is there. 2m is there. So from 2m at r more distance, who is there? From x at r more distance, B is there. 4m. At r more distance, 4m is there, right? This is r, this is r, right? So my particle system is completed, right? Now I have to find the center of gravity between these particles, right? I have to find the center of gravity between these 4 particles, right? Not a very big difficult thing, right? This is 2r, right? So if this is 3r, this is also going to be r, right? Because why? Complete is 3r. Okay. Now, okay, this is not a point actually. Mass is just a point. You need to find center of gravity from x. So first of all, if you see this 4m and m, consider this 4m. First of all, consider this 4m and 4m. What is the distance from x? 2r, 2r, right? 4m, 4m, right? 2r, 2r. So what is the ratio between the distance masses? So it's like this: 4m is here, 4m is here, x is at this point, right? 4m, 4m. What is the mass ratio? 1:1. So usually use this method, right? So 4m mass, write it here, 4m. This mass, write it here, 4m, right? So what is the least ratio? 1:1. So the total distance between them divides as 1:1. So the total distance between 4m is 2r plus 2r, 4r. 4r divides as 1:1, half, which means exactly 2r and 2r. So the center of gravity of 4m and 4m is going to be at this point, which is 8m at x. It is going to fall at x. Now we have simplified. So 6m is there. Further, who is there? 2m is there. Further, at x, what is there? 8m is there, right? Because instead of 4m and 4m, I have represented 8m, the center of gravity of those 2 particles. So it's fine. Now, what else? Now you have 6m and 2m. What is the distance between 6m and 2m? 2r. 2r. Shall we find the let's find the center of gravity between these 2 guys. Let's assume the center of gravity is somewhere here, G, right? Let's assume 6m, 2m. Center of gravity is somewhere here, G, right? What do you need to do? Write 2m here, right? So write 2m here, write 6m here. So how is the ratio going to be? 1:3. 1:3. So let's assume we need to find this distance. So let's assume we need to find this distance x bar. X bar can be found. X bar can be found. How? The ratio is dividing out 3 from 4. 3 from 4. What is the total distance between them? 2r, right? So this cancels. X bar is going to be what? 3/2r. X bar is 3/2r, right? So simply, what is the total distance between 6m and 2m? 8m. 8m is where actually? 8m is from this point. This was 2m and 8m. 2m and 8m, it was r distance. 8m. 2m and 8m. The distance between the 2m and 8m was r. 2m was somewhere here. 6m was somewhere here. Now, I have found the center of gravity of these 2. The total mass. You should represent the total mass at the center of gravity. So, what is the center of gravity from the point of 2m? X bar. X bar. What is it? 3/2r. 3/2r. Right? Right. So, now I have finally 2 masses. 8m, 8m. Now, further, I need to simplify this. I need to find the center of gravity between these 2 guys. So, it is obviously, let's assume the center of gravity between 8m and 8m is somewhere around here, G dash, right? So what you need to do is write 8m here, write 8m here, right? So in that case, what is the least ratio? 1:1, right? 1:1. So if that is the case, exactly the center of gravity is going to be in the middle. Center of gravity is going to be in the middle, right? Somewhere in the middle. So that, what is the total distance? Total distance is r plus 3r over 2 is 5r over 2. You get the exact center of this. You need to get half of it. When you get half of it, it is going to be what? It is going to be 5r over 4. So from this 8m, this is going to be at which point? 5r over 4. Actually, so this 8m is going to be on x. This is x. So from x, what is the distance? 5r over 4, right? 5r over 4. That is the second answer, right? So better use this approach, right? So this much write it here, this much write it here. So get the least ratio between them. So from the divide the length as this ratio. Divide the length as per this ratio, right? So in that case, you are going to get the center of gravity. Right? So this is easy, right? Answer. So let us move on to the 20th problem, right? So in the 20th problem, what they are saying is water and coconut oil are poured into the two limbs of the U tube as shown in the figure. They have given U tube, right? So in that coconut oil is there and water is there, right? So assume that water interface are okay. The interface is now at the right middle. So usually what you deal with is interface is like it goes horizontal, right? Interface is horizontal. So in this case, right, it's right at the middle, right? So yeah, okay. So consider the following expression. Okay, so they have given 3 expressions and then they are asking whether it's valid or not, right? So we just have to decide whether the expressions that they have given A, B, C is correct or not. All right. So the 20th problem, right? So in that, first of all, let's draw the figure and see whether what they say is correct or not. All right. Okay. So here it says this is the middle. So this is what? This is coconut oil, and this is what is this? This is the water, right? So water, right? Okay. So water and coconut oil, right? They have given the heights. So and they have marked this point to be as what? Point Q. This point to be as point Q, and this point to be as point P. It's like coinciding, right? But they have to denote it separately, that they have given a small distance between it, but it's like it's coinciding on each other, right? So in that case, let's consider this level, right? On this level, they have given this to be as H1 and H2, right? This is what? H1, and this is H2. So this is coconut oil is what is the raw note, raw oil, and raw water. So simply the first statement is pressure at point P is equal to pressure at point Q. So what can you say about that? What can you say about that? It is true. It is correct. Why? Think about this. So if the pressure at P and if the pressure at Q is different, let's assume if the pressure at P and the pressure at Q, pressure at P is greater than pressure at Q, what will happen? Can it be in equilibrium in this mode? Can it be? It can't. When you consider a horizontal line, if these pressures are different, it can't be in a horizontal line. Sorry, equilibrium. It will start to flow from higher pressure to lower pressure. That is how it is. You might have studied about fluid dynamics. When there is a pressure difference from the higher pressure to lower pressure, the fluid flows, right? So definitely, if this should be at rest, right? If this is at equilibrium, if it is still, definitely the pressure at P should be equal to pressure at Q. Pressure at P should be equal to pressure at Q. So the A statement is exactly correct, right? And also, this is on the horizontal line. It's like it falls on the same interface on the same point, but to differentiate, they have to confuse you guys. They have given it these two separate points as the P is on this liquid and Q is on this liquid, right? So obviously, you might get confused because why? So what you know is that 2 points in the same liquid, which is steel, is equal. 2 points which is horizontal, same liquid, which which is at still, is equal. But here it's like two different liquids, but still what this is at, this is still, right, horizontal limit, and like it's like on the same point, very like interface is this way. It's correct, right? If the pressure is different, simply it should start motion, right? It will move from higher pressure to lower pressure. So in that case, hope you understood that point. All right. So the next thing, H1 rho W, H2 rho. Yeah, exactly, right? If the pressure, like how can you write the pressure at P? Pressure at P can be written as, pressure at P can be written as what? Phi plus H1 rho Wg. Phi plus H1 rho Wg. It doesn't matter this inclined part. What you have always to consider, in fluid pressure, in static fluid pressure, right? What matters is the vertical height. In H rho G, when you find the pressure due to a column, so if it is this kind of a thing, still, but if you have this height, it's perfectly fine to find the liquid column, right? The pressure due to the liquid column, right? So you don't have to worry about that much. All right. So yeah, because what you need is always the perpendicular height. Sorry, the vertical height. When it comes to fluid pressure, when you find a pressure using H rho G, H is the vertical height. Remember, not slant height or anything, right? So okay, so vertical height. H1. So the pressure is H1 rho. So the pressure at Q is what? H2 rho naught G plus phi ATA, the atmospheric pressure. So when you equate these two, right? When you equate these, because like this is equal, right? So in that case, if you equate, right, rho Wg equal to H2 rho naught G plus phi to phi cancels, G to G cancels, right? H1 rho W, H2 rho naught. So the B statement is also correct, right? Okay. So but the thing is the C statement. The C statement, they have considered this kind of horizontal line, and they have equated these two points. They have equated these 2 points. Can they be equal? Think about, can they be equal? They can't, because these are not on the same liquid. Horizontal line, this was horizontal line, fluid is still, and it is like on the same liquid. Like it coincides. It's like it coincides. No gap between them, right? No gap between them. But here between them, right? Obviously these are in two different. These points are in two different liquids. Although they are horizontal, this is the, here it is not. There is no interface here. You can equate the pressure only at the interface. If the interface was here, right? If this was the interface, in that case you can consider these 2 points are in the same liquid, right? And equate the pressure. But here these 2 points are not on the same liquid. They are on these 2 points are on 2 different liquids, and also there's no interface on this horizontal line, right? So in that case, C part is not going to be true. It is wrong, right? The pressures are not equal. You can't equate this and this. It's not going to be true, right? Hope you understood. So the answers will be the third one, only A and B, right? The third answer. Okay. So let us discuss the ninth problem. Sorry, 21st one. 21st one is going to be based on waves, right? So even in waves, this is going to be based on open end resonance tubes part, right? So this is a question based on open end resonance tubes. So here it says two identical open pipes, right? Two identical open pipes, right? 21, two identical open pipes, right? Okay. Two identical open pipes of length 50 centimeters, right? Of length 50 centimeters, right? 50 centimeters. Are sounded with a fundamental note. They are sounded with a fundamental. So how do you draw the fundamental note of open end tube? So the condition is on both the ends there should be antinodes. Right? How do you do the simplest waveform so that in both the ends there are antinodes? In this way, right? Yes. All right. So okay, fine. And then they are saying initially they are at 15 degrees Celsius. Theta, this is both are in 15 degrees Celsius. Theta, 15 degree Celsius. the variation of the velocity is given, right? The variation of the velocity is given how? The variation of the velocity is given v is equal to 331 plus 0.6, right? What is it? 0.6 theta, 0.6 theta, right? Okay, so where theta is in degree Celsius, theta is given in degree Celsius. Theta should be included, substituted in theta degree. When theta changes, v changes accordingly. So the variation between the theta and velocity, they have given an expression for us to take, right? Okay, so now you do not have to go for v is equal to like velocity of sound in air, how the velocity of sound varies in temperature. V is equal to root gamma RT over capital M2. That is not required because they have already given us a expression. So you need to go with this, right? Okay, so if the temperature of one pipe is raised to 30 degrees Celsius, let's assume now this is raised to 30 degrees Celsius. 30 degrees Celsius. When the temperature is raised to 30 degrees Celsius, what happens? First of all, understand what happens when the temperature is raised. When the temperature is raised in one tube, will the fundamental tone change? Will you get overtone? Will you get an overtone? You need to understand well. In resonance tubes, when it comes to resonance tubes, right? The velocity. Sorry, when it comes to resonance tubes, right? When it comes to resonance tubes, when you change the temperature, what changes? The waveform, the waveform, or the lambda depends on the length of the resonance tube. If the length is constant, the lambda doesn't change or the overtone doesn't change. To change the overtone, you need to change the length. So because like in this, of course, length is fixed. So what will be fixed? Lambda. So lambda is predetermined based on what factor? Based on the length of the resonance tube, right? Lambda depends only on length of tube, right? So can't you find the lambda quickly? Right, you can. What is this? This 1/4 of a loop, completely half a loop, right? So lambda over 2, half a loop is lambda over 2 is equal to what? 50 centimeters. So lambda is equal to what? 100 centimeters. Lambda is equal to 1 meter, right? In this case also lambda is equal to 1 meter. It doesn't change, right? In both the cases, the same length, which means the lambda is the same. You need to understand that. So when you change the temperature, what happens? What changes is the velocity. What changes is the velocity. So based when theta changes, v changes. So as a result, right? As a result, from v is equal to f lambda, lambda is constant. When v changes, what changes is the frequency. What changes is the frequency, right? So we have to find the velocity v1 and velocity v2, and after finding, we have to find frequency f1, frequency f2. So when you get the difference between the frequency, you will be given with the beat frequency, right? So yes, simply let us find first of all v1 and v2. Let us find v1 and v2. v1 is what? 330, right? 330, yes, it is going to be 331 plus 0.6. Theta is what? 15 degrees Celsius. 15 degrees Celsius. When you simplify, you will be given with 340 meters per second. Similarly, V2 is going to be what? 331 plus 0.6, 30 degrees. Instead of theta, substitute 30 degrees. So V2 is going to be given with what? 349 meters per second. So can't we find F1? F1 can be found V1 over lambda. V1 is what? 340. What is lambda? 1, which is 340 hertz. Right? Can't we find F2? F2 can be found how? V2 over V2. We know the changed velocity, but lambda is constant always. It depends on only what? Only the length of the resonance tube. So V2 is given by what actually? V2 is given by 340 349 over 1, which means 349 hertz. So how do you find the beat frequency? Beat frequency is the difference between these frequencies. That is what? 349 minus 340 gives you 9 hertz, right? This gives you 9 hertz, right? So the answer will be what? The answer will be the third answer, right? The third answer. So let us discuss the what we have to discuss is this 22nd question. In the 22nd question, if you see, actually it's a mechanics question which is going to be based on the lesson friction, right? So yeah, so let's see. This is kind of not that very difficult. If you apply the forces, if you draw the diagram once again, and if you apply the forces properly, right? If you mark all the forces, all the required forces properly, and if you do a small like if you apply because MA, it will be pretty much a normal question, right? It's not very difficult. All right. Okay. So let us see. First of all, this is the 22nd one, right? So 22nd problem. They're saying two blocks A and B. A is 0.5, B is 1 kilograms, right? Placed on one another, on top of one another, right? In this way, placed as this, right? So and then it is the saying is sent over an inextensible string, goes over a massless smooth pulley as shown in the figure. This goes over a massless pulley. This is connected fixed to a wall, right? See, right? Okay. So now what they're asking is, now they're saying the coefficient of dynamic friction between each of the surfaces is 0.25, right? So like how many surfaces are there? Contact surfaces are there. One contact surface, another contact surface. The coefficient of friction between these two contact surfaces are going to be what? It is 0.25, right? So 0.25, right? Now, what they ask is, what is the force required to drag the block B with a constant speed? What is the force required to drag the B with a constant speed, right? So, constant speed, if you are dragging this with a constant speed, what should be the acceleration? Acceleration should be 0, right? So, you need to drag this with an acceleration 0. When you drag this with an acceleration 0, this will move forward with an acceleration 0, right? You need to understand that. All right. So now let's mark all the possible forces. Let's mark all the possible forces and just let's apply because it makes pretty much basic, right? Okay. Tensions, 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 tensions. If there is a contact surface, there is definitely a reaction force involved, right? One contact surface RA, another contact surface RB, right? So what else? The masses, the weights of the masses, right? So 0.5 means 5 Newton, and what else? 1 kg means 10 Newton, right? So are these the only possible forces? Are these the only forces acting on these objects? No. When this is moving forward, there is friction between, right? So always friction will act opposite to the motion, right? Friction will act opposite to the motion. So this is moving forward, the friction is going to act backwards, right? F1. So this is going to move forward, friction, like, so this is going to move forward, this is going to move forward, right? So this is going to move forward. So there is once again a friction surface, sorry, a contact surface, therefore F2. Friction by this surface on this object is F2, right? So according to Newton's third law, every action has an equal and opposite reaction force. You need to know that this F2 force the friction on this guy should be acting on which direction? That direction. F2, right? Now it's completed. Now it is completed. Now we have to just apply and F equals MA now, right? So can't we find F2? F2 can be easily found. How? F2 can be easily found. F2 is equal to mu, but the reaction force acting on this object RB, right? F2 is equal to mu is 0.25 RB. What is RB? RB is equal to 5 newtons. Right? The reaction is equal to the weight, 5 newtons. Right? F2 is equal to what? F2 is going to be equal to it's going to be equal to 1.25 newton. Right? Okay. So shall we apply shall we apply F equals MA to this B object? To this B object, let's apply F equals MA. What is the forward? What is the force in the forward direction? Capital T. What is the force in the backward direction? It is F2. What is the mass? What is its mass? Mass is 0.5. What is the acceleration it is moving forward with? 0. T is equal to F2. Right? So the tension is also equal to what? 1.25 Newton. Right? That is also found. Now, simply let us move on to the object B. Right? Sorry, object A. Object A. Let's move on to object A and let's apply what? Object A, and let us apply F equals MA. F equals MA in the it is moving in this direction, so let us apply in this direction, right? So what is the force acting in this direction? Capital F. Capital F. What is the backward forces? Minus T. T is the direction. F2 is there. Also F1 is there. F1 is also there. Is equal. What is the mass? 1 kilogram. Acceleration, it is moving forward with what acceleration? Acceleration 0. Constant acceleration. Constant velocity, which means acceleration 0. Right? So before you apply, we need to find F1. F1 is what? Mu what? Mu R A. Mu R A. Mu R A. So when you find R A, you need to be very careful. What is R A? R A is equal to addition of both these downward Newton forces, right? 5 Newton and 10 Newton, right? So mu R A is what? R A is 5 Newton and 10 Newton. 5 Newton and 10 Newton, right? So 15 Newtons. 15 Newtons. Mu is 0.5. 0.25. 0.25, right? F1 is what? F2 is going to be this value. So let us substitute all. Capital F minus T is what? 1.25. F2 is what? Mole. Minus 1.25. What is this? F1 is 0.25 into 15 is equal to 0. You can subject this and find F force. What is F force? F force is going to be 6.25 Newton. Right? 6.25 Newtons. The answer will be the fourth one. Right? Fourth answer. Fourth answer. When you take equilibrium for the system, right? When you take equilibrium for the system, RA, upward force, is equal to, so this and this. So this RB cancel with this RB. Another RB is there, right? This and this cancels. So upward RA is equal to 5 plus 10, right? So that is what I wanted to say. So I missed, and now it's clear, I guess, right? So the answer should be the fourth answer. So next problem that we are going to discuss is the 23rd one. So if you see, there's a lot of graphs and all given. Anyways, this is not going to be very difficult if you use the method of elimination to come up to the answer, right? So always remember, like, even this method can be used, right? So if you can't come to the answer directly, so use the elimination method. Okay, so we'll check whether this whether a certain solution is going to be correct or wrong. Like if it is wrong directly, so eliminate. So and then shortlist your answer to a certain few solutions, and then think in detail and come to the solution. That is how you use the elimination method, right? Okay, so here a projectile suddenly explodes into two fragments with equal masses, right? Remember, the important things here is two fragments, two equal masses, right? So underline two equal masses at the highest point, underline highest point. So this is how you need to categorize the important things in the paper, right? So whenever you are given with the paper, whenever you read it, so with whatever you feel it as important, please underline, right? So underline and then analyze, right? So it will be it will help you to focus on the required things, right? So because like questions are going to be given in a very lengthy way, so better quickly either shortlist the important things, right? To underline it, right? Okay. So if one fragment falls vertically, that is falling vertically downwards, as shown in the figure, which of the following diagrams best represents the path of the other fragment, right? This is what happens. This is just before explosion. Just before explosion, a mass of simple m, let's assume, was moving with horizontal velocity v just before the explosion. Just I'll draw, right? So just after explosion, at this point, if the explosion occurred, right? Let's assume at this point the explosion took place. In that case, one particle actually moves downwards, it seems. And they are saying equal masses means m over 2. One is moving downwards initially. They have shown that. They do not give us with what velocity and all. They have mentioned one just after the explosion moves down. So the other particle should move in which direction? The trajectory is asked. They are asking you the trajectory. Trajectory means the path of the second particle. So think about this well, because like how did I draw that? The initial like just before collision, how did I figured out that this was moving in the horizontal direction? Means like just before the collision, the complete object was moving in the horizontal direction. So how did I come up with that? So to come up with that, they have mentioned at the highest point, the explosion occurs at the highest point. This is the point P. The P is the highest point at this point. Alright. So at the highest point, it will not have any vertical velocity. It will have only horizontal velocity. That of course you know, projectiles, basic projectiles, right? Okay. So now, right. It's like this. It was initially just before collision. It was horizontal. So according to principle of conservation of linear momentum, right? According to principle of conservation of linear momentum. Principle of conservation of linear momentum is used here to solve this problem, right? It should be like just before the collision, the linear momentum just before the collision should be equal to the linear momentum just after the collision. That is how it should be, right? So, you know, when it comes to linear momentum, they do have a direction also. Initial linear momentum was it was in this direction. It was in this direction, all right? So if that was in this direction, right, horizontal direction, which means like how about the after collision, the resultant velocity after the collision, the resultant velocity of the two trajectories after the collision should be also in the same direction, but this is moving downwards. So the other particle should move which upward. Should it move upward? If it moves upward, okay, upward to downward cancels out and no resultant. It can't be after the collision. There should be a resultant velocity that should be in this direction. So it should have upward velocity as well as a horizontal velocity. This upward velocity, this velocity cancels out, and this is going to be equal to v. Not equal to v, in the same direction. Both should be equal in the same direction. Resultant. This cancels, and it should have. So what will be the resultant? It should be something which moves in this way, right? So obviously first answer you can eliminate. It's not going to be the answer. Second, no. Third, no. Now you need to decide between 4 and 5. 4 and 5. Why? Because both 4 and 5, if you look it properly, it's going to have this kind of a motion. Both the fourth and the fifth one, right? It's going to have the same projectile shown, right? Right. So in that case, what can we do? What can we do to decide which is the answer? Right. Think about this. Think about this. Now, I will assume what is this mass? This mass is m over 2. Let's assume after collision, this is having a velocity u. So I will apply for just before and just after conservation of linear momentum. M into v. Just before the collision, the linear momentum is m into v. Just after the collision, conservation of linear momentum with forward direction. Just before the collision, it was m into v. Are equal. Just after the collision, this is having a downward velocity, so m over 2 into 0, right? And because you do not have to write about this because it has a downward velocity. It doesn't have a horizontal velocity. So forget about this. Forget about this velocity because it's in the horizontal direction. What you have is to consider only this m over 2 into u. M over 2 into u. So u is simply going to be what? 2v. So this u is going to be what? 2 times v. So the actual trajectory is what? If the collision did not happen, it should be in this way. So if it didn't collide, it will move what distance? Let's assume a d distance, right? With what velocity? v. But due to the collision, the velocity, the horizontal velocity of this m over 2 particle became 2 times v. So it should move within the same time. It should move twice the distance. Now, because the velocity of this small particle, the fragment after the collision, it has become twice the initial velocity. If it had v velocity, it should move this kind of a distance. Now this u is 2 times v, so it should move what? d twice the distance. So the trajectory is going to be somewhere like this. So the answer is going to be the fourth answer, right? So this is going to be fourth, right? The fourth is the answer, right? So a basic question if you know the proper theories, right? So most of you guys might come across straight away. Okay, so if it has a downward velocity, it should have upward velocity, and you will select what the first one. It's not, right? So because why initially it had a horizontal velocity, so therefore the resultant of these two these two fragments, these two particles, the resultant velocity should be also be in the horizontal. So therefore this should have a upward and a horizontal velocity. Like it should have a velocity in this direction. It should have a velocity after collision in this direction, right? Then only it balances. This cancels. This becomes okay, and then becomes double, right? How you know how I came to that? Apply conservation of linear momentum. Okay, so let us. What we have next to discuss is the 26th one. 26th is a hydrostatic question, if you ask, right? It's a very basic question, but the thing is, you need to understand, you need to read the question well. This question, of course, if you did not read the problem well, you might guess the like you might know the theory and all, but still you might make mistakes because of not reading the question well, right? So the thing is, this is it. They're saying a copper block is hung over a beaker, okay, right? A copper block is hung in three ways. Position 1 is such that the block is partially submerged. I'll draw and then you figure out whether you understood the question correctly or not. Position 1. Partially immersed, right? Position 2. Fully immersed. Right? Position 3. Position 3, right? Fully immersed, but lies or it is at the bottom of the surface, on the bottom of the surface. If you do not understand this, you might make mistakes at this point, right? So Understand this way. It is on the surface, which means if it is touching the surface, some other forces are going to also come into the question, right? Okay, so let's assume the upthrust is U1, okay, B1. They're saying buoyant force means upthrust force, right? So this is pretty known. Buoyant force means upthrust force, right? This is V2. This is V3, right? So how do we write the upthrust force? V is equal to V rho G, right? So in all these cases, rho and G is constant. Rho means the liquid's density is constant, G is constant. What changes is only the volume, right? If you see V, what is V? V means the dipped volume. You need to understand when you write the upthrust, the V represents the dipped volume, right? Dipped volume. This dipped volume, right? In this case, the dipped volume is this much. In this case, the dipped volume is this much. So B1 dipped volume is, in B1 dipped volume is less. In V2 dipped volume and V3 dipped volume is the same. These two dipped volume is the same. The same amount is dipped. I mean immersed. The volume of the cube which is underwater is the same. So exactly, if V is the same for both these, so then buoyant forces are going to be the same, right? Buoyant forces are going to be the same. What can you say about the buoyant force? This is less, which means the buoyant force is also less, which means these two are higher and this is lesser, which means you can come up with what answer straight away. You can eliminate 1, 2, 3. All these three can be eliminated. You have only to choose between fourth one and fifth one if I'm correct, right? Yes. Now, what you need to check is the reading of the balance. When an object is dipped inside a fluid, the reading of the balance is going to be the apparent reading. It is not the real reading, it is the apparent reading. We call that as the apparent reading, right? So, what will this apparent reading be, right? What will it depend on? So, the apparent reading, right? Apparent reading, a spring balance directly reads the tension which acts below it. You need to know that a spring balance directly reads the tension acting just below it, right? T, 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 T. So T1, T1, T2, T3. So what I uh, need you to understand is, right? So apparent reading means straight away the tension T1, right? So this T1 is going to depend on what? If you apply equilibrium, for this one, you apply equilibrium, T1 is equal to what? Weight, W is the same in all the cases, W minus B1. This is what? T2 is equal to W minus B2. What is this? Be careful. Be careful. Apart from W, there is another force. What is that? Is it's touching on the surface, which means reactional force will also be exerted on the object by the surface, right? So when you take the equilibrium, T3 is going to be equal to W minus B3 minus R. So who will have the least reading? Who will have the least reading? These T values are the reading, right? Apparent reading means the T values. I told you. Who will have the least reading? This guy will have the least reading. W3 is the least reading. And then who? And then who? And then this guy, because the upthrust, sorry, yeah, and then this guy, because the upthrust is high. If the upthrust is high, this is less, right? And then this guy, because on him only the upthrust is the lowest. So therefore the apparent reading is the highest. So what is the reading? That is the answer, the fifth one, right? The fifth answer. So next, what we are going to discuss is the 30th one. So this is a graph problem. They have given a FT graph of a station of an object of mass simple m, which initially starts from rest. right? Variation is given. Right, so this is the T graph, right? So what they are asking is at what time interval will the object once again become at what time interval once again the object will have an instantaneous zero, like suddenly when will it come to zero velocity at once again, like initially it was at zero, once again when will it come to zero velocity, that is what at what time interval. So from an FT graph, what can you obtain from an FT graph? You need to analyze whenever you are given with the graph problem. You need to see, okay, with the area, what can I get? With the gradient, what can I get? So obviously, with the area of FT area means what? FT area is will give you change in momentum, right? The area of an FT graph is going to give you change in momentum. So if the area is positive, what does that mean? If the area is positive, positive change in momentum. If the area is positive, positive change in momentum. If the area is negative, negative change in momentum. Negative change in momentum. Positive change in momentum and negative change in momentum. Increasing momentum, decreasing momentum. Increasing momentum, decreasing. Right. Likewise, you can consider. Right. So initially this is at rest. Initially this is at rest. Now it has a initially it has a positive, but it has a positive area until what? Until t equal 40, it has a positive change in momentum. Positive change in momentum, which means its velocity increases. Change in momentum. What is momentum? M into v, right? So like this is constant, so it's directly proportional to the velocity. So positive change in momentum means initially its velocity is increasing. It's, how much was its velocity increased? Its velocity is increased until, let's assume it was increased up to this area, this amount of area. Once again, when there is a negative change in momentum, its velocity decreases. Its velocity decreases. Velocity increased how much? This amount of area. Now, when you move to the below part from 48 seconds onwards, once again, there is a negative change in momentum, decrease of momentum, which means the velocity decreases. So velocity decreases, keeps on velocity decreasing. When you, because it started with zero, increased how much? This amount of area. Can you show me, can you form this amount of area from the negative side also? Yes, exactly. You can form that amount of area. Right? This area and this area is equal. This area and this area is equal. You can make a calculation and see, right? So, and this is 70th second. So the increase in velocity at up to t equal 40, increase in velocity, right? Increase in velocity, and from t equal 40 to t equal 70, decrease in velocity, and the increase in velocity is equal to decrease in velocity. The increase in velocity is equal to the decrease in velocity. So finally, it should come to zero. And it should come to zero at the 70th second. Increasing velocity is equal to decreasing velocity. Increasing velocity equal to decreasing velocity. Increased, decreased. The initial velocity as the initial zero, here also zero. Right. Once again, decreasing velocity, right? Which means like, forget about it. This, can you cancel this and this? Like obviously, what happens is this and this cancels. This and this cancels, but this is remaining. This is remaining. The increase of velocity in the negative sector, right, is a portion is remaining. This to this cancels, but once again you can't make this whole part. If there was this kind of a at this moment, once again the velocity might have become zero. This decrease in momentum, like negative momentum, positive momentum, cancel, which means zero. But what they have given is only up to this point, t equal 120. So within 120, once again you can't make it zero because the area proportions are not getting cancelled out. Right? This to this gets cancelled out, but a small portion is remaining, which means its velocity is not going to become zero. Right? Once again, which means the answer is only it will become zero only at 70th second. Right? So the second answer is the correct one. So next we have to discuss about the 41st question. This is going to be based on fluid mechanics, right? So fluid mechanics question, like fluid mechanics, fluid dynamic part, right? So simply you have to apply Bernoulli, I guess. We'll see. And as shown in the figure, right? A horizontal pipe ABC connected to a water tank with a large cross-sectional area. Underline the word large cross-sectional area. You will have to get an idea out of that word. The internal cross-sectional area of the pipe B is twice that of C. Initially, at water located at D and K, once the tap is opened, what would be the height of the water level? What would be the height of the water level in the vertical tube at B? Right. Okay. Assume the water is steady and streamlined. Okay. So that is given because it's like a hint. Okay. You need to apply Bernoulli to solve this. Like, right. So they are giving a hint. Let's use the hint. Right. So let's draw the diagram first. It might be helpful. So the positions are, this is A, B, the tap D, and the point C, right? So this is, let's mark this as A, B, C, D, E. Let's mark this as E, right? So the height of this is given to be as H, right? So they have initially mentioned, if you see, the exactly connected to a large cross-sectional area, right? Water tank with a large cross-sectional area. From this, what can you like gain? From that, what you can gain is that the velocity on the surface is zero. Like, based on A1, V1, A2, V2 and all, when the area is very high, like the velocity, the drop in the velocity, like it starts to move with a very small speed, right? When the area is very high, velocity is very small, right? You need to know that, right? In that case, we can, since they have told it has to be as very large, we can consider it to be as zero. The velocity at this, the velocity of changing of this is zero, right? Obviously, like it's negligible, right? Velocity at this point is zero, right? Okay, and the pressure is what? P ATA. The pressure at this point, okay, when this tap is opened, right? Let's assume the water is flowing, right? Then water is flowing and it has rised to a height, let's assume H, right? Now water is moving out here from a velocity, let's assume VC, right? VC. Velocity at this point is zero. What is the pressure at this point? PATM, exposed to the environment. Remember that. So I will find this velocity VC in terms of H. For that, what I am going to do is I'm going to apply Bernoulli's principle to point E and C. To point E and C. So, what is the total pressure at that point? PATA. What else? What is the unit? What velocity is zero? Therefore, the kinetic energy per unit volume is zero. What is the? If you consider this as the potential energy zero level, right? You consider potential energy zero level, right? What is the height H? So rho g h equals to, what is the pressure at this point? PAT. And what is the velocity at this point? Therefore half rho Vc squared. Plus what is the potential energy? Zero. It is on the zero level, right? So this cancels out. Rho to rho. So Vc is equal to 2g h rho. Right? I have found Vc in terms of h. Right. So why did I find that? Because now I'm going to do something. I'm going to somehow find the velocity at this point also. Velocity at this point. V. How can I find that? By applying A1 V1 equation of continuity. So B and C equation of continuity, right? Equation of continuity, right? Equation of continuity. What is the area? Area is, they have mentioned the area at B is twice that of C. If this is 2A, velocity is VB. VB into 2A. Area is A into VC, right? So A to A cancels. VB is equal to, VC is what? I found root 2GH. Root 2GH over 2, which means VB is going to be GH over 2 root, right? The velocity at this point. Now, once again, I am going to apply what you know to these 2 points for B and C Bernoulli. I'm going to apply Bernoulli for B and C. I'm going to apply Bernoulli, right? So the pressure at this point, the total pressure at point B is what? P naught PATM plus H rho Z. PATM plus H rho Z. PATM plus H rho Z. Total pressure at this point, H rho Z, right? H dash rho Z, right? That is what they are asking for, H dash. What is okay? Velocity is half rho VB squared. Potential energy 0 level. So at this point potential energy 0. Right? Do not have to consider. What about this point? So what is the total pressure at this point? P ATM, exposed to environment. So what is the velocity at this point? Half rho VC squared. Potential energy 0 level. Of the potential energy 0 level. So forget about it. P ATM cancels out. Rho cancels, right? So when you simplify, H dash G plus half VB squared. VB squared is GH over 2. Half VC squared. VC squared is 2GH. 2GH. I guess G to G cancels out. 2 cancels out. Sorry, G. H dash is equal to H over 4 H, right? So H dash is equal to H minus H over 4. H dash is equal to 3H over 4. This will be the answer, right? So the third answer, right? The third answer. Okay, so this will be the final question that we have to try in the paper 2020, right? So that is the 49th problem, that is going to be based on something related with energy, right? So in that case we'll see, right? So what that is. So the 49th problem, it says block A of mass 2 kg and B of mass 6 kg are on a frictionless horizontal surface, two identical springs. Okay, block A is projected with a speed, right, 2. Is projected with 2 meters per second, right? What is the mass? 2 kg. This was initially at rest. Right? This was initially at rest. 6 kg. Right? Next, what happens? You need to understand. If you understood this well, it's pretty easy. This comes, collides, and this compresses, and after it maximally compress, it will start to move. Now this happens. Actually, based on physics, you can explain this also, because moment of like the inertia. If you ask, the inertia of 6 kg is high because its mass is high, its inertia is high, it shows a higher reluctance to move. So although 2 kg is coming and colliding with it, it will stay at rest as much as possible. It will stay as much as possible until the maximum extension, like compression is occurred. After maximum compression occurred, obviously it will push, and this will 2 kg will push. Like because of the higher inertia, it has that ability that the 6 kg, because the mass is high 6 kg when compared with 2 kg, which means higher mass means higher inertial mass means higher inertia, higher reluctance to move, right? Higher reluctance to change its motion, not to move, to change its motion, which that is at rest. So it shows higher reluctance. So it will be at rest until the spring is completely compressed, and then only it will start to move, right? Okay. So after completely this thing, both will start to move with the same velocity, right? Both will move as one object, right? Right. So this is 2, 6. Let's assume that common velocity is v. So can't we find the common velocity? Yes, we can easily find the common velocity. How do we find that? Conservation of linear momentum in this direction. 2 into 2 plus 0 is equal to total mass is 2 plus 6 v 4 8 v. This is going to be 2 meters per second. This is going to be 2 meters per second. Sorry, not 2 exactly. Sorry, other side, right? 4 over, right? Okay, it should be 4 over 8 is 0.5 meters per second. So, since we know the velocity, can't we find the initial velocity? We can find the initial kinetic energy. Initial kinetic energy can be found. Initial energy, not the kinetic energy. Initial kinetic energy. Like initial kinetic energy is what? Only this guy had a velocity, so half 2 into 2 square, right? So 4 joules. Can't you find the final kinetic energy? Can. Half, what is the system? 6 plus, what is it? 6 plus 2, right? The 6 plus 2 is 8. It is moving with what velocity? 0.5 square, right? 0.5 square. If you simplify, you get 1 joules. So what has happened to this? What has happened to this initial kinetic energy? Like what has happened to the 3 joules? The 3 joules were used to do work against the friction. Sorry, against the what? The 3 joules was used to compress the spring. So the work done to compress the spring is stored as the spring strain energy, the elastic potential energy. So the elastic potential energy is what? 4 joules minus 1 joules, 3 joules, right? So from completely 4 joules, remaining is 1 joule. Lost 3 joule. It is not lost actually. It is used to do work against the, like to compress you need to do a work, right? So it doesn't automatically compress. You have to push it. To push you have to use some of the energy that you have. 3 joules was used. So that work that was used to push the spring was stored as the elastic potential energy of the spring. So that is what they are asking, and the answer is going to be 3 joules, and the answer will be the fourth one, right? So guys, that will be the end of the 2020 paper. So I will be posting more questions, like more question papers, more past paper questions I will discuss and be posting. So to stay tuned, please you can consider to subscribe, and if it is like if you have any questions and all, you can leave the questions in the comment section. I will ask like, as much as possible. I will try to reply to them, right? So and yeah, so yeah, share it with your friends, and then try to get something out of this, and right. So that is it. So like yeah, thank you.